Alright, so problem number 1. Actually, before we do that, on the top of your sheet somewhere, I want you to write these 5 equations. I just numbered them over there so you can say we're going to use equation 1 or whatever. Okay, problem number 1. What is the average speed of a cheetah that runs 67 meters in 6 seconds? Is there... I'll let you guys copy it down first, sorry. Everybody got the equations down? Alright, number 1. What is the average speed of a cheetah that runs 67 meters in 6 seconds? Is there any acceleration that's going on here? No. Remember which equation we use if we don't have acceleration?
V equals delta x over t.
Yep, so we're going to use v equals delta x over t. Alright. Do we know what v is? No. We don't know v. What is delta x? 7 meters. What's our time? So what's 67 divided by 6? The unit for velocity is meters per second. Everybody okay with that one? This one, obviously not that hard, but what's going to mess you up is once you've done a bunch of hard problems, coming back to this one. You're going to be like, there's no way it can be this easy. It can't be this easy. There's no way it can be this easy. So like, if you don't see anything about acceleration, it's just that equation. So don't like freak yourself out when you come back to something like this. So if you don't see anything about acceleration at all, it's just going to be that equation. Alright, number 2. A jet on an aircraft carrier can be launched from 0 to 60 meters per second in 3 seconds. What is the acceleration of the jet? Alright. We have 3 variables here, and we're looking for a third. What are we looking for here? Acceleration. So the first time I write down is A equals question mark. What is 0 meters per second in this case? Initial velocity, so we have VO equals 0. What is 60 meters per second? Final velocity. And what's 3 seconds? Time. Alright, so once you write down what we're looking for and the variables we know, which of those 5 equations over there, or actually which of those What equation can't we use since there's acceleration? First one. Alright. Which of those four equations over there has the variables that we have here?
And the second.
4. We have VF, VO, A, and T. So we don't have delta x, so we can't use any with delta x in them. So we need to use VF equals VO plus AT. So our final velocity is 60 seconds, or 60 meters per second. Initial velocity is 0, plus acceleration is what we're looking for, and time is 3 seconds. So we end up at 60 meters per second equals A is 3 seconds. Divide both sides by 3. What's 60 divided by 3? 20. So our acceleration is 20. And what's the unit for acceleration? Meters per second squared. Everybody okay with that? Erase this. The equations seem a little less intimidating now. How much time does a car with an acceleration of 7 meters per second squared take to go from 34 meters per second to 20 meters per second? Okay, is it deceleration? Okay, so 3. What are we looking for? Okay, there's kind of a trick to this one. What's our acceleration? Is the car speeding up or slowing down? Slowing down, so what should our acceleration be? Negative. Does that make sense to everybody? We could also make our velocity negative and then our acceleration is positive. All that matters is it has the opposite sign of what our velocity is. But it's easier to just make the acceleration negative. What's our initial velocity? Our final velocity? Alright. So, what equation are we going to use? 4 again. I didn't really mean to do that when I made up these problems, but it just worked out that way. So we got VF is VO plus AT. So our final velocity is 20 meters per second. Our initial velocity is 34 meters per second. Plus our acceleration we said is negative 7 meters per second squared. And our time is what we're looking for. Subtract 34 from each side, we get negative 14 meters per second equals negative 7 meters per second squared. That's time. And what's our time? 2 seconds. What would have happened if we had not made our acceleration negative? We would have got negative time. I think it makes sense to have negative time. So if you get negative time, something has gone horribly wrong. Right. Questions on that one? These have been relatively easy so far, but this next one's a little more difficult. Right, number 4 says, car accelerates from rest at a rate of 2.3 meters per second squared for 14.8 seconds. The car then slams on the brakes and decelerates at a rate of 4.8 meters per second squared until it comes to a stop. What is the total displacement in the car? Alright, how many parts are there to this problem, do you think? How many different things are happening? 2. Does that make sense to everybody? So in part 1 the car is accelerating, in part 2 the car is decelerating. I'm going to say 1 and 2. Alright. For part 1, what do we know?
Acceleration,
Acceleration's what?
2.3.
2.3 meters per second squared. What else do we know? Time? What's our time?
14.
What else do we know? Initial velocity is 0. Okay. What are we going to have to find in part 1? We're going to have to find, we're going to end up finding our final velocity and the distance. So what we're going to do is we're going to find the distance for part 1, the displacement for part 1, the distance or displacement for part 2, add them together at the end. That make sense? Okay. So how can we find delta x with the variables we have there? What equation? Yep, 3. So we're going to use delta x equals VOT plus 1/2 AT squared. I never make the tops of my 2's, so they look like fishes. So we have delta x equals 0 plus, and that makes, since VO is 0, it makes the whole term 0. Is everybody okay with that? Plus 1/2 times 2.3 meters per second squared times 14.8 seconds quantity squared. One thing, just to make sure you guys realize, the units on this are squared. You don't square the number. Do you understand that? But you do square this number. So what does delta x equal? Anybody get it?
17.92.
That makes sense.
251.896.
251.896 meters. What probably happened? Did you remember to square that?
I thought you said no one squared the.
Don't square this one. This one just has the unit squared. This one you do square. Because I've had people like do 2.3 squared because they unit squared. Sorry if I probably added a little confusion there. Alright. So questions on how we get this? Alright. Now, I'm gonna go over to part 2 before I do the final velocity for that part. Alright, what do we know in part 2?
Acceleration.
Yep, we know the acceleration is what?
4.
Yep, is it?
Negative.
Yep, slowing down to negative 4.8 meters per second squared. What else do we know in part 2?
Final velocity.
Yep. Final velocity is going to be what?
0.
0. Everybody understand why the final velocity is 0? It's coming to a stop. Alright, do we know anything else for part 2? We're going to be looking for our displacement in part 2 as well. Is there any way we can solve for anything with those 4 equations up there for part 2? Nope. We need at least, to use any of the bottom 4 equations, we need at least 3 numbers to start working with. From those 2 numbers we can get anything, but we need at least 3. We only have 2. what from part 1 is going to carry over to part 2?
And the final velocity,
The final velocity becomes, for part 1 becomes what for part 2?
the initial velocity.
Initial. Does that make sense, everybody? So we're going to find the final velocity here, and then bring it over as the initial velocity for part 2, and then we can solve for delta x. Okay. Now, we want to find final velocity. We want to use an equation that does not use the delta x we found. Why do you think we want to do that?
We messed up finding delta F.
Exactly. If we messed up finding this delta x and we use it to find final velocity, then we're messing up final velocity too. Does that make sense? So we're going to do, what equation has these 4 in it? Number 4, yep. We do VF plus VO plus AT. VF equals 0 plus 2.3 times 14.8 seconds. Our final velocity is what? So
34.04 meters per second.
34.04 meters per second. Okay, so that becomes VO over here. So now, what equation do we have that we can solve for delta x with those variables? What? Not 3, because we don't have time. 5. 5 is the only equation that has VF, VO, A, and delta x. So I'm going to do VF squared equals VO squared plus 2A delta x. So you get 0 equals 34.04 meters per second quantity squared plus 2 times negative 4.8 times delta x. So what's 34.04 squared? I'm going to bring it over to this side.
$1,158. 7216. Or 7.
That's fine. Use your round to the tens or hundreds place in here. I'm not overly concerned with sig things usually. And we get equals negative 9.6 times delta x. So divide, oh, this would be negative because I brought it over there. So now we divide both sides by negative 9.6, and what do we get for delta x?
$120.7 meters.
120.7 meters. Alright, so what's our last step going to be?
Yes.
Adding the two displacements. So our final answer for delta x is called delta x total equals 251.9 plus 120.7. And what do we get for that? So that's how far the car went, speeding up and slowing down. Questions about that one? How do you guys feel about that one? How many people could have done that on their own to begin with? How many people could do one like that now, on your own? Maybe. Anybody feel like they couldn't do it on their own even now? Not me. Alright. Now have you guys do the rest of class here. Turn it over. Try to do number 5 through 8. 6 is like one we just did. 7. Actually, let's talk about 7 real quick. 7 says a car accelerates from rest at a rate of 3.1 meters per second squared for 10.3 seconds and continues at a constant velocity for 26.4 seconds before it starts to decelerate at a rate of 3.4 meters per second squared until it comes to a stop. How far did the car go? So, how many parts does that one have? 3. Part 1 is going to be the same as part 1 from this. Part 3 for that is going to be just like part 2 for this. What equation are we going to use for the middle part? The constant velocity part. 1. And what's our velocity for that constant velocity part going to be? The answer for part 1's final velocity. Does that make sense? Alright, so when you get to that one, it's going to be 3 parts. It's a little bit harder, but it's kind of the same idea as this one. Alright, so when you guys get started on those, I will grab the answer key and put it up in front of you so you can see it, and I'll be around to help you if you guys get stuck in anything. And if you don't ask questions, I will just harass you. So, there's that. I'll set the answers right there for now. And I'll turn off the